In model problem 1, we need to find an expression for the derivative of f of x equals the square root of arcsine of 7x. And when I'm reading that out loud, I heard the word of several times, square root of arcsine of 7x. That's a clue to me that I'm going to need to use a chain rule. And because I said it twice, I'm thinking I'm going to need to use the extended chain rule. So remembering what the chain rule is, I need to figure out what's the inside function and what's the outside function here. So on the very inside, I see the 7x. In the middle, I see an arcsine, and on the very outside is the square root function. So I'm going to need to take the derivative of the square root function to start with. And if I don't remember how to take the derivative of the square root function, I might want to rewrite this as arcsine of 7x to the 1/2 power. Now I can use the power rule to pull down the 1/2 to help me find f prime of x will be 1/2. I rewrite the inside arcsine of 7x, and the power is going to be reduced by 1, so 1/2 minus 1 would be negative 1/2. Now, I'm not done. The chain rule says I need to now multiply by the derivative of the inside. So I'm going to need to multiply by the derivative of the inside. So the inside was that whole arcsine of 7x. Okay, well, now I'm not done with the problem. There's still more calculus to be done over here. This is going to be another chain rule. And I know that's going to be another chain rule because if I read that, I'm taking the derivative of arcsine of 7x. It's a function inside of another function. I always need to do a chain rule if I have that situation. So let's keep going. F prime of x is equal to, I'm going to copy down the start, 1/2 arcsine of 7x to the negative 1/2 power. And now the derivative of arcsine of 7x, if I look back on my reference sheet, I can see that's going to be 1 over the square root of 1 minus the thing on the inside, that is 7x being squared, times the derivative d dx of the stuff on the inside, 7x. So finally, my answer is going to end up being that f prime of x is equal to 1/2 of arcsine 7x to the negative 1/2 power times 1 over square root 1 minus 7x squared times derivative of 7x is just going to be 7 right there. And if this is on the free response, I could certainly box that in as my final answer and move on. If I was on the multiple choice, they might simplify this. They might try and hide this from me in some clever way. Maybe they would rewrite this negative 1/2 as 1 over the square root of, with the arcsine in the denominator down there. Lots of clever things they could do to try and hide that from me on the multiple choice, but remember, on the free response, full points for anything that's equivalent to the correct answer. Let's go ahead then and look at model problem number 2. So in model problem number 2, we are asked to take the derivative of ln of square root sine x cosine x and then evaluate when x is equal to pi over 4. So lots of ways I could think about this problem, but I'm going to try and simplify things and make my life easy right here. I'm going to remember a couple log rules. So to start with this, recall two things. First of all, if I'm trying to take the log, the natural log of the square root of something, just call it a. Remember that this is really ln of a to the 1/2 power, and I can always pull down a power, so that's really a 1/2 ln of a. Now, that's going to be really helpful because I've taken, I have a square root function on the inside of this log here. I can simplify things and make it just 1/2 ln of the thing on the inside. Now, there's also one more rule. So, and also, don't forget about this one. If we have ln of a times b, we have a product, and it's on the inside of a natural log here. We can actually rewrite that as ln of a plus ln of b. So we can take a product on the inside of a log and we can rewrite it as addition between logs like that. Now that's going to help us a whole lot because when we look at what we've actually got on the inside here, instead of having to do an extended chain rule that would be really complicated, something messy like we did up in model problem number 1, instead of doing that, let's simplify this first and then try and take our derivative. So let's see how that goes. So we've really got that ln of the square root sine x cosine x. Well, that would actually be equal to 1/2 ln of sine x cosine x, like this, using the first property up here. So then we can use the second property and simplify our lives even a little bit more. This is really then 1/2 of, and you got to make sure you get your parentheses right here or else you're going to end up in trouble. It would be ln of sine x plus, that's ln of sine x plus ln of cosine x, and close our parentheses like that. You could distribute the 1/2 if you wanted to, you don't have to. So great, now we've simplified what it is that we're actually taking the derivative of a little bit, and let's see what's going to happen here. So then if we actually take the d dx, what are we going to get? So to get we're going to get over here, let's take the derivative. All right, the 1/2 is still going to be there. That's not going to change anything. It's still going to be on the outside. But on the inside, when we take the derivative of ln of some stuff is going to be 1 over the stuff, so 1 over sine x, times the derivative of the stuff, thanks to the chain rule. So the derivative of sine x is going to be cosine x. Over here, we're going to take our derivative. We'll end up with plus 1 over from the ln of cosine x, so 1 over cosine x. And we have to multiply by the derivative of cosine x, which would be negative sine x. So times negative sine x. Let's close our parentheses right here. And maybe simplify things a little bit, make it a little bit neater. We've really got 1/2 of cosine x over sine x. And then the minus here is going to turn that into a minus sine x over cosine x. Okay, so that's what our derivative is. We need to evaluate it at x equals pi by 4 and figure out what we're going to get here. So then at x equals pi by 4, we have, let's see, all right, well, it would be 1/2 of the cosine of pi by 4 over the sine of pi by 4. Well, just thinking about pi by 4, remembering on our unit circle, a pi by 4 angle right here is a 45-degree angle, would have square root of 2 over 2 and square root of 2 over 2. Cosine and sine are going to be the same thing, so cosine over sine is just going to be 1, and sine over cosine, well, that would be 1 as well. So 1 minus 1 here, I know that's going to be equal to 1/2 of 0 is just 0. So my final answer there is going to be 0.